In Malaysia, road accidents and electric vehicle-related failures are sometimes caused by preventable internal vehicle faults. Issues such as battery overheating, abnormal charging, discharging, or undetected crash impacts often go unnoticed until it's too late. As electric vehicles become more common on Malaysian roads, ensuring the safety of internal systems, especially the battery system, has become increasingly important. In 2024, there were some cases reported in Malaysia where electric vehicle cars caught fire due to crash damage and during charging. To address this, we propose a compact, AI-powered in-vehicle monitoring system for electric vehicles. This system will detect faults in some major areas: battery status and temperature, charging abnormality, predict remaining battery life (RBL), smart output and alert mechanism, and sensor fusion for crash detection. This system will monitor the EV car using the Raspberry Pi and some other sensors to detect and alert to abnormalities, predictions, and failures. This system will also integrate an AI decision-making system that can process and respond to abnormal readings intelligently, then provide the LCD output and speaker voice alerts to warn the driver. The hardware components involved are Raspberry Pi, used as the central controller to read sensor data, process logic, display outputs, and run lightweight AI tasks, and the INA219 current or voltage and DS18B20 temperature sensor, which will monitors the battery voltage, charging current, and detects abnormalities like overcharging, overheating, or low charge. The MPU6050 will act as an accelerometer for impact or crash detection and use the GPS module to locate the crash or thermal events. The alert system will use the LCD display to show the textual alerts and use the speaker and Pi audio output to deliver the voice-based alerts to the drivers. The software components involved are Python programming as a main language for reading sensor data, processing logic, and driving outputs. After that, use the sensor driver scripts to individually fetch and convert raw sensor data into a readable format. The AI-based logic module will also be used, where it can implement rule-based detection or lightweight logic to identify abnormal conditions. This will also use the SD card or internal logging on the Pi for data storage. The system powers on when the EV is started. The Raspberry Pi boots up and initializes the monitoring software. Upon startup, the system sets up all required sensors and modules to ensure battery thermal conditions, monitor real-time voltage and current, detect sudden movements or impacts, track vehicle speed and position, and use camera module or Raspberry Pi camera to record video before and during possible accidents. The system collects data from all active sensors. The system processes battery data to detect issues like overheating by detecting whether the battery temperature is above safe levels, and abnormal charging or discharging by collecting the data from the sensor to identify charging too fast or slow or unexpected discharging. For crash detection via sensor fusion, to improve accuracy and reduce false positives, crash detection relies on an accelerometer to detect sudden impact, harsh braking, or swerves, and GPS will identify abrupt speed drops or no movement post-collision. For the output and logic, the LCD display will show the sentence and alert sound if an error or abnormality is detected. For the battery and charging abnormality detection, the condition that will trigger the output when overvoltage, overcurrent, and overheating occur, for a crash detected, the LCD will display the message, and the speaker will provide the voice. The GPS will log the impact location and save the camera frame and sensor data snapshot, then it will trigger an emergency message via GSM. This system, by focusing on battery health and real-time crash detection, addresses two of the most critical concerns in EV usage: thermal safety and passenger protection. Through continuous monitoring using temperature, voltage, and current sensors, the system detects abnormal charging, discharging, and overheating risks before they escalate into dangerous events. Additionally, AI-based prediction of battery life allows for informed maintenance decisions, extending the lifespan of costly EV batteries. The system performs intelligent crash detection by fusing data from accelerometers, GPS, and camera sensors, minimizing false positives and enabling precise impact detection. Real-time voice alerts and display messages ensure that the driver receives timely warnings without distraction. These systems are also compact, cost-effective, and scalable. This AI monitoring system offers a smarter, safer, and more sustainable approach to EV safety management. By combining predictive analytics with real-time alerts and sensor fusion, it sets a new standard for in-vehicle safety solutions.